Thanks, everyone. It's great to have you all here. We'll be splitting this tutorial in half, so Maxime will start. First of all, we're going to set up the environment for all of you guys. So we handed out Post-it notes. If anyone doesn't have any, please raise your hand. Those are to indicate whether you've already installed your environment. So if you're struggling to install, please put up the red sticker. One of us will come around and help you and potentially set you up with an environment. Yeah, thanks so much. Maxime will take it away, and I'll take over halfway through.
Hi, everyone. So I'm Maxime. I'm working for Anaconda. I'm a software engineer there. Today we're going to talk about HVPlot, which is a plotting library, and that gives you a lot of power. We'll start with the setup. So I don't know if you could get the screen. So these are like the simplest instructions for you to get set up. You have this tiny URL link that is PyData HVPlot 2022 to get to this document where you can find how to install the environment and the datasets. You will need to run the notebooks from this tutorial. This uses Anaconda project. It's not the purpose of this tutorial, but it's a super nice package that allows you to declare your dependencies, the data you depend on, and to package that in a very nice way. There's also a way to install the dependencies with pip. I recommend you download this zip file over there. It's about 150 megs, so it might take a while. I hope it's going to be fine. And then you will find instructions on how to install the dependencies. In the README, there is a requirements file. We also provide a binder link, but binder is super limited in resources these days. So it's very likely it's not going to work. But yeah, if you don't manage to install anything with conda and pip, you can try this. And if really you can't do anything, actually, this whole tutorial, or this tutorial can be found on this website, holoviz.org. So the same notebooks we will run are already there executed. Just you won't get all the interactivity. So I'm going to let you keep working on your setup, and I'm going to do the introduction to this tutorial. I think when you think you're set up, like you have installed the dependencies and everything, you should try to run this notebook, the 00 _ setup. If you can run it without any warning, without any issue, then you're good to go for the rest of the tutorial. Oh, sorry. Yes, definitely. So it's PyData HVPlot 2022 at tinyurl.com. Ah, yes, definitely. So when you're set up, if you can put this green post-it on the back of your laptop so that I can have an overview of who's ready to go. Thanks. That's an excellent idea. So for the online audience, you have this document you can access at this tiny URL, and it gives you instructions about how to install the dependencies and the data sets and how to obtain the notebooks that we are going to run with conda. If you don't have conda installed, you can install miniconda first. And you can also install the tutorial and the dependencies by first downloading this zip file and then extracting it, and you have more instructions in the README how to install the dependencies with pip. You can also try your luck with binder. It's pretty unlikely it's going to work because it has limited resources these days, but you can still give it a try.
Remind everyone to put the green up if they.
Yes, and when you're ready, everyone. Oh, I see a lot more greens. That's nice. Don't forget to put a green post-it on the back of your screen. Nice. Yeah. So I will get started. And anyway, the beginning is quite a lot of is a bit of talking. So you still have time to get set up before we actually run the examples. Yeah, but just to remind you, if you think you're ready, run this notebook, the setup notebook. That is in the examples in the tutorial folder. If it runs fine, you're good to go for the remaining part of this tutorial. I'm going to zoom in because I think it's really small, right? Is it fine in the background, screen size? Looks fine, okay. So, yeah, welcome to this. One bigger? Okay, thanks. So welcome to this tutorial. This is the Holoviz HVPlot tutorial. Holoviz is a set of tools. It's also a group of people who's been working on these tools for open source tools for many years, like I think about 10 years. They are dedicated to data visualization, and they really are meant to help you in your data analysis, like workflow, getting data, exploring this data, testing a hypothesis on your data by visualizing it. Then when you're fine with your analysis and you want to generate figures to share them with your colleagues and your boss, you may also want to be able to deploy your plots and your small dashboards to your colleagues so that they can interact with the data if they have more questions. And we also want each stage in this process to be customizable and that you can improve over time. So that's where the name Holoviz comes from holo, that means like whole, entire, complete. So doesn't Python already cover all of these stages? Well, sure it does, because it's been there for like about 30 years now. This is a view of the visualization landscape of Python. It's, I think, even a condensed view. So it's a lot of different technologies and a lot of different packages. So you see some famous ones like matplotlib over there. There are packages and technologies that are built on top of JavaScript, some other on top of D3 or Vega. Why are there so many tools? Because they were solving different kind of problems. So some solve, like, they allow you to get very quickly to, like in a one-liner, to simple, nice plots. But then you can't really customize that much. Some are, like matplotlib, I think, for example, are very good at creating plots that you can print. So it's very good for research, for publication. Some others are good for interactivity in a Jupyter notebook, like these examples. But then they can be kind of weak or not super performant when you want to use them in batch processes. So for instance, overnight, you want to create tons of figures of your data. Some are good for deployed servers, so you can like have them embed them in a website, but they don't work so well maybe in Jupyter. And as a data analyst, data scientist, you want to be able to work in your notebook and then to just deploy the exact same thing on a server. And finally, some are like good at small data set, but suddenly you get a lot more data and it's just going to break or be very, very slow and not performant. So Holoviz is trying to tackle all of these like these sort of weaknesses by providing an ecosystem that has all these capabilities, part of it at least. So Holoviz is meant to work very well in a web browser, so in a Jupyter notebook and also on deployed servers. You just write Python scripts. You don't write like JavaScript or front end. All the interactivity works the same in Jupyter as long as on the server. And one thing it's almost the philosophy of Holoviz is shortcut, no dead hands. It means that you will be able to get pretty quick to a point where you're satisfied, like a plot that you wanted, but then you always want to customize it a little bit more, or your boss or colleague says, oh, maybe you should do that. Sometimes you get stuck there with a tool. You can, okay, I can't do anything more with this tool. With Holoviz and some of these packages, you can always just go a little bit further and customize things more. And so yes, as much as possible, Holoviz tries to use the API that you know, and this is really going to be about HVPlot. So you see, like, Holoviz is this suite of tools. It's a small ecosystem. They all work very well together. I'm going to focus today on HVPlot, but there are other ones, and they will be mentioned in this tutorial. HVPlot really is the entry point to the whole ecosystem. It is based, so I'll talk a little bit more about HVPlot later. Panel is a library with which you write Python code, and you can create dashboards that you can deploy. So basically, you can create like some small websites, just writing Python code, so no JavaScript, CSS, HTML. Holoviz is what powers HVPlot mostly. So it's a way to interact. It's a way to you create objects that in a notebook will display themselves as plots, like curves or points or polygons. It's really a way to wrap your data with some options and some operations that later displays themselves. GeoViews is an extension of Holoviz so you can map geographical data and display geographical data. Data shader, which we will talk about, is a way to plot really a lot of data. So Jean-Luc gave a talk yesterday in the afternoon. If you missed it, you can watch it in a few days or weeks on YouTube. Param is a way to declare. So Param is really maybe the library, part of all these libraries that is the less dedicated to visualization. But it's also very cool when you write some algorithms or to declare your interface when you write some API. It's typed parameters. So you declare a parameter that is a string, and then your users, if they use a parameter that is not a string, get an error automatically. It's also more than that, but this is already very useful. So Holoviz has decided to, it builds on the Python visualization landscape, and it has decided to build around Matplotlib, so it supports Matplotlib. It also builds on Plotly, so you're all available to use Plotly, and Bokeh. And there's also support for some other some other libraries, but it is less. It's really around this main three. Yeah, so this is what this diagram shows here. And so in this tutorial, so what you actually got by installing the tutorial, you have a full long, like 4 hours tutorial. But today we'll focus on the first part of it that is really dedicated to HVPlot. If you have time or if you feel like it, you can keep going in doing the tutorial, and you will learn more about Panel and Holoviz and how to use these tools in a more advanced way. The tutorial we use earthquake datasets, and so we will analyze this data, and we will create small dashboards to explore it. And we'll focus on the first part on hvplot.plot. So if you have used pandas before, you may have used the .plot API, so the .plot method, to create plots. So it's sort of like flat API with a lot of parameters, like read CSV. Instead of doing .plot, after installing HVPlot, you can do .hvplot, and most of the API is just the same, so you can use the same parameters that you would use for Pandas API, except that it extends it and you get more power. We also have .interactive, with which you bring interactivity and the ability to build some pipeline that you can control with widgets, And you will see with example, it's easier to explain with an example. And we'll not talk in this tutorial so much about panel, but it will be mentioned a few times. So I'm jumping to the, yeah, I encourage you now to run the tutorial with me, the notebooks. And there are a few small examples, so I will give you time when we come to them so that you can run them and just play around with the data. So I already mentioned the pandas.plot method, and HVPlot so builds on top of this API, but it's not the only one. You have also Xarray, you have pandas bouquet, so you have now a collection of tools that have built on top of this API, and that is very common to a lot of users. And I think it's very easy to enter in this world and just to create quickly some plots. So yeah, we'll start by running the tutorial. So we will use pandas to read some data, some Parquet files. But just so that you know, we could have used like Dask, or we could have used QDF, like to use your GPU resources. HVPlot allows that, so you can create plots from Dask data frames if you want to, for instance. So I'm just going to read in the data. If you have any problem while running this thing, just let me know. So we have a data set of about 2 million points. So we have earthquake events, so they have a timestamp, and they have a lot of different properties, their magnitude, their depth. We also have their location, so longitude, latitude. For this tutorial, we will just create a small data frame with just a fraction of the data, because 2 million points for some tools is like too much. They can't really handle that. So, but you will see later that with HVPlot, you can handle as many points as you want. And we will switch between these two data frames in this notebook. So first we show with the, what does the traditional .plot method of pandas do. So you call it with .plot.scatter here in this case. So we're creating a scatter plot with the longitude as the x-axis and the latitude as the y-axis. There's a small example here that you can try. So changing the inline here with widgets and see what you get. So yeah, I encourage you to try that. You'll see that you get actually a way to interact with this plot. You can zoom in on your plot. You can pan. So this is already quite nice. You get some interactivity. You can't really know what's the data associated with one given point, but it's still a little bit better than the pure static plot if you want to do some exploration. Now we'll switch to using HVPlot directly. So to use HVPlot, you just need to import it this way, hvplot.pandas. And instead of calling .plot, we will call .hvplot. So what you get is actually a bouquet plot. So I didn't know how much of you were aware of this library, but it's a Python library that I think was started quite a long time ago at Anaconda. And it allows you to interact so much more. So it's not a static plot. It's a plot with which you can interact. So you can pan. You can zoom in with this. You have a set of tools on the right, so you can zoom in. You can zoom in with your scroll wheel. If you zoom in on axis, you can actually just change things with respect to this axis. And you also have the possibility to hover data points. And so by default, with this data set, how we've configured it, you don't get super useful information, just the latitude and the longitude, but we can customize that to get, for instance, the magnitude. So you see already you get, with just like a single import, hvplot.pandas, and changing .plot to hvplot, you get a tool that's pretty useful when you want to explore your data, and more than a static plot. Yes, so there's something that's noted in this in the comment here is that this plot suffers from what is called overplotting. So even though this is the small data frame and we don't have that much data, we can't really see the density. We can't really see the density of all this of the earthquakes. We can't really say anything because we just have too many points, and we haven't really tried to do anything to try to see that density better. What you would do, really, the first thing you would do, and you can try this out, this is the exercise, is you would change the transparency of each point. So, well, you may try with 10% or 20% or 50%. By trying with 10%, well, you get something a little bit better. You see that this is, you can see this is more dense over here. You can start to see the shape of mountains. That's a little bit better. Another way, something else you could have done, instead of doing of creating a scatter plot, you could have created a hex bin. So by plotting hexagons, and in each hexagon, the color of each hexagon represents the density, so the number of earthquakes that were in this area. So I don't know if it's better. It's just another way to represent the data. You're exploring it. But we'll see better ways to explore this data set. Yeah. So with a flat API like the one like .plot, usually you have a lot of options, yeah? So it's not super easy to find all the options you're able to pass to this API. So there is a utility, hvplot.help, and you pass the string of like the kind of plot you want, so for instance scatter. And when you try that, you'll see you get a pretty large output with all the parameters you can pass. So there are different kinds of parameters. There are generic parameters. There are data shader. Now we're not using data shader. There are geographic options, and at the end, the very end, you will see these style options. These style options are the ones that are passed to the plotting library, the backend, that is bokeh. So when we used alpha, but we could have used all of these other like options to parameterize how we want our plot to look like. This utility here accepts some parameters, so if you don't want to see everything, all of that, you can just select like, okay, I just want to see the normal parameters and the style parameters. Okay, so we saw that the plot we just created suffered of overplotting. We just had too many plots. So we will use data shader now to circumvent this problem. And what data shader does is that it will create an image. Instead of like plotting like all the points, it will create an image, and in each pixel there will be by default the count, so the number of points you would have had. You just to get this data shader plot, you need to specify rasterize is true. There are options to say how the color mapping is spread, but we will use like the default options by the option that is the most suited for the default case when you start the first look you have at this at your data set. So that's a much different plot, right? So you don't get points anymore, you get an image. And well, you can see really it's way better. You can see the density, you can still zoom in and out, and the image is recomputed every time you zoom in and out. And hover, you can also hover over these plots, and you get in each pixel, so it's really adapted to your screen. Each pixel, the count of earthquakes, So yeah, I encourage you to play around with this kind of plot because it's very nice. But
Sorry,
yes,
can I repeat the question in the microphone just for the online audience?
yes.
Can you please repeat your question so I can repeat
Yeah,
it?
can you repeat your question, please?
Yeah, question is there an easy way to zoom in and out? Because this does not seem easy. Okay, it is easy, but
I'm just using the touchpad, not using any.
yeah, the touchpad may not always work for everyone.
And you also need to use to select the wheel zoom tool on the right. That's the way. That's the way. Okay, so this plot, actually, we were still using the small data frame, but we will now use the full data set. And you'll see you get very quickly. So we have over 2 million points in the data set. And it works very well. You would have tried that. You would have tried to plot to make a scatter plot of all these points. Probably your browser would have crashed because it's too many. A matplotlib plot would have been fine. It would have taken maybe a little bit longer. Yes. So yes. So as I said already, but it's fair to repeat it again. So we use pandas now as our entry point, but we could have used Dask, Xarray. There's also support for streams. Streams, it's to support streaming data intake. There is like a library that offers data catalogs, and so you can have an HVPlot interface to that. GeoPandas, if you're used to geodata, and also NetworkX for graphs. There's a small exercise. So if you could try that, select a subset of the data. So for instance, only the magnitudes that are greater than 5, and plot them with a different color map. So with another CMap parameter. I'm just going to give you like 1 minute to try that.
Subset from the small subset or subset from the big data?
Well, from the big data, and you can use rasterize equals true.
So repeating the question for the online audience, subset from the small subset or subset from this big data set?
Yes, thank you.
This was the answer to that.
Yes.
So I think while we're waiting, we've had another question here as well.
Put it on Slido yet?
Okay, it's on Slido.
No, it's not on Slido yet. I have a question. Is it possible to set the color, the legend, to something that looks a bit nicer? Because you have a lot of, like to have like integers on the colors.
Integers here.
Yeah.
Oof.
Whoa.
That's scary. This color map is actually, it's computed, it depends on your data. So I don't think with this option hist you can't set the color map itself. You can change the way you compute the color map. So you can use log. Here you get something you're more used to, but you get a little bit less information. Yeah, and you also have the option to have linear, but linear here is not going to be useful at all because the density is really in some tiny clusters of the whole data. Okay, so this is the solution to the small exercise. You can pass a lot of different values to CMap, color maps that are supported by Matplotlib, Bokeh, and also another package that is part of Holoviz that is called ColorSet. Next, onto statistical plots. So dot plot, like .hvplot, not only support scatter plots, but also you can have like histograms and other kind of statistical plots. So what we will do first is that we will, what are we going to do here? Oh yeah, okay, we're just going to clean up our data set to remove nans. And then we will plot a histogram with dot plot, the dot plot API of, oh, I'm going to remove that. So with the dot plot API of oh, yes?
It's also the same for you that the legend disappeared when you changed the color map?
The
The
legend,
question was, is it also the same for you that the legend disappears when you change the color map?
do you mean here there's no legend?
Yeah, you don't have the scale.
Oh,
Yeah.
Yes, you don't have a scale anymore.
It is because I have used the data shade option. If I use Rust, right? Oh, it doesn't come back. Okay, no, messed up. What did I do wrong here?
If you remove the column, it should show again.
okay, that does indeed sound like a bug. You can explicitly set color bar equals true.
Oh, did that?
Someone is saying color bar doesn't make any sense if you have one color.
It does make sense because it's not just one color. It's like a color bar of a color map of red. So it does make a little sense. Yeah. So thanks for the question. And back to the histogram. So just to show you the support that HVPlot has to histograms, you also get, so you still get a bokeh plot, so interactive. You can hover and you know how many points you have in each bin. So this is again very useful compared to a static plot. So the small exercise here, if you could create a kernel density estimate plot of magnitude instead of a histogram.
So maybe a quick reminder to everyone, in a few minutes we're going to have a questions round, and also for the online audience, if you have any questions or comments, please put them in Slido, and we'll take questions from there and then from the live audience. Approximately 5 to 10 minutes from now.
So to get kernel density estimate plot, you just have to call hvplot.kde by specifying that you want it to be with respect to the magnitude. It's an estimate of the probability density function. Okay, and the last part of this tutorial is going to tackle categorical plots. So we will, in this data set, add some categories with respect to the depth of the earthquakes. We'll use this simple table to define them between shallow, intermediate, and deep. We are just going to do some pandas foo to create these categories and create a new column, insert a new column in our data frame. I can show you what that looks like. So we have now a new column called depth class with shallow, intermediate, and deep earthquakes. And we will create a histogram, and by saying that we want to see a difference with respect to their depth class with the by parameter. What we get here is an overlay of different histograms. Quick trick is that you can click in the legend to deactivate partly the plots so that you can see better those that are underneath. You could start to dig more into your data set and try to see what's going on at like greater magnitudes. Oh, if I manage to. You still have hover that is working, and you can get hover from multiple histograms in the overlay. Small exercise, so add in the previous call subplots equal true to see what's going on. and width set to 300 pixels. So with this simple change, instead of getting an overlay, you get a composition of 3 different histograms, and they actually happen to be linked. So if you zoom in on one particular axis on one plot, it will also zoom in on the other plots, and same for PUN. Their axes are linked automatically. And okay, so now we've got like an overlay of 3 different plots. We've got a composition of 3 plots, but maybe what you would want is just one plot and the ability to switch between the plots. And this is what we call grouping. You activate grouping by using the group by parameter and giving it the name of one of your columns.
Yeah, I don't know the answer. Okay.
So you'll see, I'll try to get this, maybe change that a little bit. Yeah, that's better. So by automatically what you get by using group by is you get your plot. So here it's a bivariate plot, but you also get a small widget that allows you to select your group category, and by changing the value you select with this widget, you get the ability to explore your data set and see the differences. To keep going, like analyzing further our data set, instead of just classifying by depth, we could classify by magnitude. So we are going to define some magnitude class and associate them a name like minor, light, moderate, strong. And we will create a heat map out of this, because now we have a data set with 2 different categories. So we have 2 different columns with 2 categories. And so we can pass these 2 categories as like a heat map, and each bin here, each sort of cell will have the count of earthquake events. So we can see that in this data set we appear to have like where we have the highest density is like light magnitude earthquakes and shallow. So okay. So yep. So this is the end of this first part of the tutorial. That was an introduction for you to HVPlot. I hope you get the feeling that just by doing one import and calling HVPlot instead of .plot, you really get a tool like with bokeh and with the possibilities of HVPlot and data shader that is really super powerful, and you don't have to learn a lot of different APIs. This is quite flat, and you have to remember just a few parameters or find them in the documentation. So I think we get to the question time. So if you have questions now, please do so.
Yeah, there are questions online, so we'll take those first, and then we can look around the audience. So, so one question has already been answered. Can you please share the GitHub link? These are on Discord in room A5, A6. The next question, is there a standard way to combine Uber H3 geospatial index and HVPlot?
Could you repeat the question? I just didn't get it.
Is there a standard way to combine Uber H3 geospatial index? I do not know what that is.
Uber.
And HVPlot. So Uber like the
I think
company,
yeah,
or the German word?
Yeah, I think Uber gets you like hexplots. Yeah, hexplots.
Hexplots.
They have like, they've been to work in 15 resolutions. I think that's an index in 15 different resolutions to create hexagons on over all of the Earth, and then it's mapped to a latitude, longitude, which is very nice for aggregating stuff.
Yeah.
But plotting hex codes is usually shitty, so I was wondering if there's something already nice.
Right. We have no interface with any package from Uber to I don't remember the name, H3, I think it's the name of this package. And no, we have no interface to that, and we just create hexplots like out of the box from bokeh.
Hi.
Hi.
Is there a way for HVPlot to work outside Jupyter Notebook?
Yes, so you can actually save your plots. So there is like, you can do hvplot.save on the object that is returned by each call. And so that's a way to have a static file. But we also have a library that is called Panel. And Panel is a dashboarding library with which you can just like deploy and create like dashboards. And hvplot objects, you can embed them very well in this sort of dashboard.
Okay.
Any other questions?
Hello. Yeah, so I'm getting an error every time I'm importing HVPlot. It is asking me to install Git. I say cancel, but every time I do, I even call something to plot it. It opens this window and says you should install Git. And I say cancel, so I have to every time say cancel,
Okay.
and then it runs.
Okay, you shouldn't do that. That's very strange. So
Okay.
we'll have a look, okay?
Okay.
So is there a link maybe in the Discord where you can file bug reports?
Absolutely. So there is it's just on GitHub. You can find holoviz/hvplot and file bug reports there. No, I think we're good.
Okay, a second part then.
Yes. Hi everyone. I'll take over from here. Okay. We have it working. Perfect. All right. So we're going to move on to the next notebook. If you are running on our Anaconda cluster, ideally you shut down the previous notebook when you move on to the next one, just to limit resource usage a little bit. That's a general advice anyway. All right. So far we've kind of created simple plots, but usually you kind of want to combine different layers in your plots, right? You might have a scatter plot, and you might have highlight certain bits. And so you want to have a way to combine those together or create layouts of multiple plots. And that's what we're going to be looking at next. So again, we're going to load our data set here. I hope you can see that. Is that size? I might go one larger. All right. So we've loaded our data set again. We're going to import HVPlot pandas. And now we've created we're going to do some resampling, weekly resampling of this data to generate us a weekly plot of earthquakes. Right? Quite nice. We get all the interactivity we're used to. In fact, bokeh has nice daytime axis resolution so that when we zoom in, we kind of get more information about dates. And that's all nice. But what actually kind of magically, all these plots just appear. And how does that actually work? Well, Jupyter has this idea of representation. And this visual wrapper basically appears if you put an object at the end of a line. And so if I kind of suppress the output, put a semicolon here, we don't get any output. And then if we use the print function, we actually get a different view of this. And this is a textual representation of what this object is. And in this particular case, this line plot is a so-called Holoviz curve element. What does that tell us? Well, it gives us a little bit of information. It tells us this is a plot of earthquake counts over time, which is nice. But what does that affordance actually give us? Right? It's an object, nice enough. You're familiar with map-all-up figures. But why is that a nice thing? Well, these objects, you've got a variable on this object, and you can compose these objects together. So if I do a similar resampling of now do weekly mean magnitudes, I now have two different objects, and I can compose those together in some form, right? So I have this plot of weekly counts, I have this plot of weekly means. I could compose those using the multiply operator, and the multiply operator basically means stack them on top of each other. In this particular case, doesn't really make sense, right? So really what we want to do is compose them into a layout. So that's what we can do with this plus operator instead, and that gives us a layout of these two components. In this case, basically it kind of fills a number of columns, and using this .cols call here, we can set to say how many columns of this do I want, right? So I can do 2 columns, but that's a bit too wide. So in this case, I do 1 column, and now I have these 2 plots composed together into one. I will make this slightly larger. Okay, that's pretty nice, right? If you're coming from matplotlib, you're used to kind of creating subplots, and this kind of provides an easy way of composing these plots together and quickly generating layouts or composing multiple plots together. Okay, so another nice thing we can do is adding a 3rd dimension to our plots, right? So a scatter plot has 2 dimensions. It has the x and the y, but you might want to actually color by some dimension, or you want to scale the size of the points by some dimension. And HVPlot also makes that very easy. Just like in the matplotlib interface, you can set the C argument, color, to a particular dimension of your data. So here, we can now color our points by the magnitude and kind of see some patterns here. For example, in the Pacific region, you have these really intense earthquakes, and similarly here. And always, all HVPlots basically return you a Holoviz object and give you a bit of information about kind of what we're actually plotting. So here we're plotting a scatter plot of longitude against latitude scaled by where the color is scaled by the magnitude. So printing is always a good way to kind of actually understand what is this thing that I'm plotting after the fact. And next, so we've now created one thing that we've kind of have to think about a little bit, which you usually maybe don't think about so deeply, right? You're creating a scatter plot that you've got an x, you've got a y. Which one depends on which other one, right? Really, a scatter plot usually plots some variable against some other variable, while here, really, we're plotting physical locations. And so Holoviz makes this distinction between dependent variables and independent variables. And scatter, this doesn't make sense. Y is longitude on its own here, and latitude grouped in with the magnitude. HVPlot and Holoviz make this distinction of dependent and independent variables, and here, so if we say we want to plot longitude and latitude, we really should be expressing those as points rather than a scatter plot. And that's just conceptually cleaner, because now we're expressing that kind of magnitude is a variable of the longitude and latitude in some sense, rather than plotting them against each other. Okay. Other things we can add, we've added a color. Other things we can add, for example, we could scale by size, but we can also kind of reveal more information about our data by kind of adding these hover columns. So basically, we have a bunch of columns in our data frame. We want to add some more context, more information into this plot, but kind of we don't want to visually vary too many variables, so we add them to the hover information. And now when we hover over this, we get not just the longitude and latitude and the magnitude, but we also get the place and the time of this earthquake, right? So really, we can really drill down into this and get all the information we want, right? And that's a huge benefit of this interactive plotting mechanism, rather than having something like matplotlib where it's static and you can't really, you've just got an image that you're dealing with. I think we are running a little bit low on time, so I'm going to skip this exercise and just keep running here. The other thing, the whole way through here, we've kind of plotted these geographic locations, but it's really hard to get a physical context for where these things actually are, right? So HVPlot helpfully includes various tile sources. These come from Holoviz, or defined in Holoviz, and so here's a tile source of kind of Esri satellite imagery, and we can use that and now use the multiply operator to compose these tiles together with our plot, and now we can actually get an understanding of kind of where are these points actually on this map. Before, you could kind of guess based on kind of if you knew a little bit about where earthquake regions were. But here now we can actually get physical context, right, and see, well, yeah, this is the Pacific. This is kind of just off New Zealand, for example. There's a ton of earthquakes. So that's quite nice. And we don't actually, so here we've kind of shown you that, yes, we make this composition of these two elements, right? But in actual fact, HVPlot helpfully provides you a tiles argument, which lets you kind of add geographic tiles very easily without having to do the composition. Another thing kind of we've already talked about kind of so far, we've worked entirely with tabular data, pandas in particular. But HVPlot has support for a wide range of kind of data libraries, and if you're not familiar with Xarray, it's kind of the pandas for raster data, gridded data, sometimes referred as, so basically images, right? And so we can easily, we're just going to clean up this data a little bit. This in particular refers to this data set here that we've already downloaded and are loading now, are population densities. So we want to provide context, right? So earthquakes, yes, it's interesting. It's an interesting data set, but really the real-world impact is what we're interested in. And so we're now wanting to combine this density information with the earthquake information. We can again use this rasterize argument, which kind of helpfully, this is a huge image, right? This is kind of 4,000 by 8,000 pixels. Dumping that into your browser as just an array it's I think tens of megabytes. And so this rasterize argument, just like in the previous scatter case, it regrids the data depending on our zoom level, right? So if I zoom in further, we get more and more detail until we're down to kind of the resolution of the actual underlying image. And so in this way, we can get a ton of information about this data just by using this rasterize argument. All right, and as a final step, we're going to put this all together, right? So we have our rasterized population estimate, density estimate. We've got our scatter points with our hover information scaled by color, and we're going to now relay those two and get kind of a plot of some of the most severe earthquakes and how they relate to the population density in that region. And so this gives us a lot of context, a lot of information, and it's really quite easy, right? We've kind of, in just a couple lines of code, we've loaded these two data sets, we plotted it, we regridded it using data shader, and then we can easily compose it using this multiply operator. So this is a super nice and quick way to kind of generate compositional plots. And this leads us into kind of the core philosophy. We want to make things, low-level things, easy. We can kind of choose precisely where to go, but in the end, we provide a high-level API, but in the end, you can still drill down where you need to go. You can customize every little bit of it, and if you kind of drill down further into this, really, we've kind of underlying this are just bokeh plots. So if you really need to customize every single detail about your labels, you can still drill down into kind of the actual bokeh representation of this, and then tweak every little thing about your plot. So if I import Holoviz here as HV, what we get back is just a bokeh figure. And similarly, actually, we've just added support to kind of plotting with matplotlib and with plotly into HVPlot, such that using this simple representation, these custom few lines, we can generate a plot and then still customize it in very, very detailed ways. And that's always been our philosophy in all of our packages. Yeah, sorry, I've been running a little bit fast. We don't have a ton of time. I'm going to quickly do a demo of kind of a very powerful feature in HVPlot, and then we're going to get back on track and kind of go through the last little bit, which was the promise of this tutorial, which is to build little actual data apps using HVPlot and some of the tools around it. So I'm just going to run through this notebook very quickly, and then, yeah, we'll go to the next one and get some more information. So one really nice feature is the composition is a really powerful feature that we get out of the fact that HVPlot is based on Holoviews. The other nice feature is that we can kind of compose things, but then we can also use operations that are defined in Holoviews to drill down further. So there's this linked selections operation in Holoviews where we can compose two plots, tell Holoviews these should be linked, and then I can kind of select on one plot and see that selection reflected on the other plot. And so this really kind of very complex and nuanced relationships in your data can be kind of teased out this way. And again, it's really just a line of code, right? You're just, Holoviews does all the hard work of kind of finding these dimensions are linked between these two plots and then figures all of that out. And so this works for most plot types. Here, for example, we've again got our geographic plot with a slightly different tile source, and we've overlaid a histogram of the depths of the earthquakes. And so I can now kind of tease out where I can ask questions of this data, right? I can say, where are earthquakes which are very deep in the earth, right? And so I can select here on this histogram to say I only want earthquakes to show up which are at a depth of 500 plus, or whatever. And immediately this is reflected in the geographic plot. And again, just a single line, right? We just have our plots, we tell it these are linked, it figures that out, and then links them for us. Underneath, this is basically expressed as a so-called selection expression. So we can look at the selection expression here. Basically, we've made the selection here. This is now expressed as this expression where depths are greater than 520 meters, I guess, and less than 673 meters. And then we could, using this filter method, we can apply that to our data set to actually kind of, okay, I've made some selection. I now want to work with that subset of data that I've actually selected, right? So that's pretty nice. That's just something I wanted to show you real quick, just showing you the power. Kind of, we've seen composition is easy, building these plots is easy, but you really get a lot more power even then, right? And this works with a huge range of plot types, including kind of on these really large data sets, millions or billions of data points that you're plotting with Datashader as well. All right, now let's get back on track. This is, I think, probably the last notebook we're going to get to. There's quite a lot more content in this tutorial, and I encourage you afterwards, if you're interested, to keep running through it. Kind of we get into kind of building actual applications and so on. But for now, I'm going to take you through this interactive pipelines notebook, which is going to introduce you to some very powerful, easy APIs to build some apps. Okay, so the first thing we're going to do is import Panel. Panel is a dashboarding library we've been building, which makes it really easy to kind of prototype interactive components in a notebook and then deploy that separately. So I'm going to show you some affordances that provides, and then we're going to dive into kind of this HVPlot interactive API to dig into kind of what we can actually practically do with that very easily. So panel objects, again, just render themselves. In a notebook here, we get this widget that reflects, the current value is reflected into Python, right? If I set it from Python, it's also reflected into the front end. I can kind of, to demonstrate that this isn't tied to Jupyter in any way, I'm quickly going to basically launch a separate, this show call here creates a running server, which you could kind of run entirely separately from Jupyter and serves this as a separate application, right? And so if you wanted to deploy this, you could easily deploy this. Obviously, a single widget isn't something you would want to deploy, but some of the apps that we're going to see and build now might be something you want to share. Yeah, so if you play around, you can see, yeah, if we kind of change the value of the slider and then rerun this cell, you'll see it'll be reflected in Python. Okay, we're going to, again, run our imports, load our data, kind of pre-process our data a little bit, just to get it in a nicer format for working with, right? We're just going to select the columns we're interested in. We're going to kind of select just data that falls within kind of nice geographical limits. We can ignore kind of polar and, earthquakes in the polar regions, just to have a slightly nicer data set. Okay, and now comes the magic part. Right? By importing hvplot.pandas, we've added this second accessor. So the hvplot accessor is the plotting entry point. This is the entry point for building data pipelines, data apps very easily from pandas data frames. So this interactive call here basically returns a new object, which is now an interactive object. So if I check the type of this, this is now an interactive object. It wraps the data frame. But now we can do really quite fun and interactive things with this thing. Right? So previously, we created this magnitude slider. And now we can do some expressions, such as we're going to filter this data frame with the slider. And this is just standard pandas syntax, right? That if you've used pandas before, this is something you're going to be familiar with. And we're going to say, for all magnitudes, filter this data frame and give me just the magnitudes that are greater than the value of this current slider. And so as I drag the slider now, we can see this data frame updates. So we've built a data app in a single line of kind of very idiomatic Python, in fact, pandas code. This is using the exact APIs that you're familiar with. And this interactive API works not just with pandas, but with all the other libraries that we were talking about before, Dask, Xarray, and so on. So using the APIs you already know, you can now build data apps in your browser, link kind of your selections to your data frame or to your plots. Right? And so now we use the standard .plot API again, we'll create a histogram plot, and as I drag the slider, we see this plot now update. And so super interactive, super easy, and using just the APIs that you already know. So here we've now swapped out our matplotlib plot for this HVPlot. And yeah, we can build this little application very, very easily. So other things we can do is filter by dates, for example. So here we have this date range slider in panel. We're basically going to set the start and end to the maximum date and the last date in our data, the minimum and the maximum date in our data set. And now we can kind of, we can look at that. This is start date, the end date. And this thing has has two parameters called value start and value end, which, as you might imagine, is the current value start and end value of this date range slider. So as I change that, we see that update. And now, again, we can kind of do arbitrarily complex expressions on our data set with these widgets. The kind of new thing here is that really what we're working with is not the widgets themselves, but actually parameters on this widget. And so underneath this kind of magicness of selecting with a widget lies the fact that actually these widgets have parameters. These parameters, in this case, are called value start and value end, and that's how things are actually filtered. Right? Whenever the parameter changes, it notifies interactive that the parameter value has changed and that the plot should be updated in response. And so now we kind of have this complex expression where we can filter both by magnitude and by a time range. I can drag that around, and we can build this interactive app pretty easily. So now let's try. You guys have a go at it. Do a quick exercise where we filter by the minimum magnitude, but in this case, actually use the .param value accessor to filter instead of the widget itself. That's a really important understanding. In panel, in particular, you can kind of, everything is a parameter, and so you can link everything to everything else. So understanding that kind of the parameter is what links the thing is very important. So we don't have any solutions here. So I'm just going to work through this myself as well. So we start with our DFI, which is the interactive data set. We say DFI dot mag is greater than, is greater than mag slider param.value. And this is basically underneath it all, it's equivalent to just doing this filtering. Okay. The other nice thing, right, is that we're building pipelines here. We don't have to stop. We've kind of built our filter data frame, but we don't need to stop there, right? We can create other things. We can do further analyses. We can chain our pipeline or analysis into further analyses. And so we've kind of stored this interactive pipeline as this filtered variable, and now we can create some plots from it. So we're going to kind of create a plot of the HVPlot magnitude. Using HVPlot, create histograms of the magnitudes and depth, and then we can, as you see, it automatically kind of displays the sliders that are in this pipeline, such that when I drag, we now update both of these plots, because HVPlot can track that basically these are inputs to our pipeline, and so we're going to expose those as widgets for you. So pretty cool. Just in a few lines again, we've built this interactive application that filters this data. The other thing, so this is all very centric on filtering. Really, HVPlot. So I'm going to go off script a little bit here. Really, any method can be made interactive in this way. So I might do kind of a rolling mean. And have a window here, window parameter, right? Widgets dot end slider start end 10. Call it window, and now I can kind of use that as an argument to any function that you might be used to when you're working with pandas. Sorry about that. So. So in this case, I guess that I should have used something like resample. Ooh. Oh, it doesn't like that. Sorry about that. We should have used, of course, weekly. I should have used a selector like weekly or biweekly. So I could create a select widget here to say basically 1 day, 1 week, and now I could do HVPlot. Plot the magnitude again. Okay, so we can kind of create any interactive pipeline that we want, and interactive will interpret any widget or parameter as an interactive thing to bind to this pipeline. All right, so as a last step, we're going to kind of create this interactive map. So again, we subset our data beforehand to give us a more manageable data set to work with. And now we create an interactive pipeline from the subset, again, filtering by date, filtering by the magnitude, and then feeding that into this geographic plot. And just the same, we can now kind of see, oh, that should not be flickering. We'll have to look at that. We can create this interactive plot that updates, so kind of we filter down to a single data point there. We might just select magnitudes above 6.5 and see kind of the strongest earthquakes. So you can kind of, I hope you can kind of see that you can build really, really complex applications very, very easily using this approach. One thing that we haven't covered so far is kind of, whenever we kind of displayed this pipeline, these widgets appeared automatically, right? But in actual fact, you might want to, when you're building an actual application and you want to make it look pretty, right, you don't want your widgets right above your plot. You want to kind of lay them out nicely and so on, which is something that the panel library, which can do for you. And if you kind of follow the tutorial a little bit further, we'll show you how that works. And so to do that, you kind of need to understand that when we display it, it kind of terminates the pipeline, right? It says, now we're rendering this thing, and we're going to display the layout of this entire thing. But there's a number of terminating methods, which basically turn these objects into the objects that are actually rendered underneath it all, right? And so one thing we can do, for example, is kind of terminate this pipeline into Holoviz objects. So if I call .holoviews, we get Holoviz objects, which you're familiar with from kind of the previous composing plots section, which then allows us to kind of layer on top other things, such as the linked selections that we saw before. So now I can build a pipeline that kind of is filters or aggregates your data or does any other pandas operation, terminate it into a Holoviz plot, and then apply linked selections such that we can now kind of have this interactive pipeline where I can filter my data. So we're going to unfilter, kind of include some more data again. We're going to select the subset, and all of this combines to give you the power of kind of all the power that's available in the Holoviz ecosystem. So as you can see, it's still linked to these widgets. It's still linked through these linked selections, and that's really quite powerful. So the main terminating methods are these widgets. So you can get access to the widgets yourself. You can get access to the Holoviz objects, so you can do things like linked selections. But you can also kind of terminate and say, actually, I want, from this filtered subrange, I want the whole layout. And this is now a layout of the data and the widgets. And if we print that, this is actually a panel object. Panel, again, is this dashboarding library we've been developing. And you can see here, it explains exactly kind of, this is a layout, a row of containing a column of our widgets and our, in this case, just the view of the data. How are we doing on time? 12 minutes. I do want to leave a little bit of time for questions at the end. But yeah, I hope you kind of got an idea of the power that this API provides, right? You don't need to relearn new APIs to build your interactive applications. You just use the APIs that you're already familiar with. You sprinkle in this interactive call, and then the pipeline works just the same like a pandas pipeline. Pandas method chaining works, except now you can provide parameters or widgets as the inputs. So I'll quickly demo, since we do have a few minutes, I'll quickly run through where we can go with this, right? Towards, I may actually, instead of going kind of off field and introducing another concept, I'll dig in a little bit more, some other things you can do with interactive. So you're going to have to watch me live code a few things. So far, we've kind of only seen in these interactive pipelines the ability to link widgets or parameters directly with our interactive pipeline, right? But what would happen if you want to transform your widget input before you feed it into this interactive pipeline, right? So maybe I want the title of this plot here to reflect the current magnitude selection and the current date selection, right? And so if I wanted to basically set the title parameter of this thing, how do I now do this? Well, there's a solution. Panel provides something called a bind function, and we'll see how that works in a second. So here we're going to do create a little function that formats our title for us, right? So we've got the magnitude, we've got our dates, which is the start date and the end date of our filter. We're now going to create a little f string to say earthquakes with magnitude greater than mag and between dates 0 and dates 1. Okay, so if I now call this function, right, I could do, I've got my mag slider value, I've got my date subrange value. Oh, I didn't re-execute this. Let me undo that. So yeah, in this way we can kind of format our title, but now how do I pass this into this interactive pipeline? Well, this is where pn.bind comes in. pn.bind basically means bind these arguments to this function. And so in that way we can kind of express complex things about these values that we're putting in. And so now we're going to bind to this title function the magnitude slider and the date subrange slider. And so whenever either of these sliders changes, panel.bind will tell the interactive function here to call this method again and update the title. Right? So in this way, we now have a title which is linked to the magnitude, or not. Demo effect here, apparently. Oh, this is probably not the correct. Okay. Mag subrange. Yeah, I give it the wrong slider, so we want mag subrange. And now, whenever I change the magnitude, not just does the plot update, but also it calls this function with these two values and recomputes the title. And so in this way, we can kind of create any arbitrary inputs, dynamic inputs to any function, which is quite nice.
Sorry, what did you change just now?
Sorry, okay, previously, just a second ago, the question was, what did I just change? I'd made a slight mistake before, right? We have multiple magnitude sliders here. We have the date subrange and the magnitude subrange. I'd passed in mag slider, which is a slider we used somewhere above in the notebook. So I just fixed it. Okay, cool. And as so what we can do again here is now we've built this little application, right, using panel, and if you follow the tutorial, we can now deploy this as a nice little application entirely separately. You can put this on your server and kind of share your interactive results with other users, maybe not even technical users, right, who don't know how do I run this notebook, how do I work with Jupyter. You can kind of share your data science insights directly with users. Panel also has nice things such as templates where you can kind of create a little application around it. Earthquake, let's call this the Earthquake Data Explorer. I'll assign this to a variable. I'll say append our geo.layout to it. And then let's show that instead. And now we don't just have, we get a nice little template around it. We can do further things such as kind of, well, actually, I don't want my widgets to be in the place they are, right? I want to place them in the sidebar, geo.widgets, and geo.panel. Oh, I should probably have, yeah, that's, sorry. I should have re-executed that. And now we have this, we've basically created a nice little templated application. It has features such as kind of resizing, and all of that in just a few lines of code, right? Again, we've just created our little template, added our widgets to the sidebar, added our plot to the main area, and created a dashboard that you can share with anyone. I think I'll call it a day here. I do encourage you to kind of follow through. The next sections will kind of take you through some of the basics of using panel, kind of combining HVPlot, panel, and Holoviz in powerful ways, and then finally take you to building full dashboards.
Could you go back to the TN
Yes, absolutely. Sorry about that. Yeah.
The question was, go back to the dmpl command, please.
Yes.
Okay, so I guess we have a question round now then.
Sounds great.
A few questions from online. Some of them were already answered on Discord, so let's start with the ones which haven't been answered yet. Okay, what is the status of Holoviz compatibility with other IDEs, for instance, VS Code, Interactive Mode, Spider, PyCharm, etc.?
That's a very good point. So generally, we love notebooks. All our documentation is centered around notebooks. We work well in, so VS Code also has notebook integration. It works in there. But if you do not like to work in notebooks, for whatever reason, there's very valid reasons not to like notebooks, you can use panel to kind of have a auto reload function where you just script on one screen and see the result reflected in the browser on another screen. And that's a perfectly valid way of working. We may have to kind of improve the documentation around that a little bit. If you look at, there's a nice little blog post for the last panel release, which kind of walks through that a little bit. I think auto reload is in here. Yes. Oh, no, it's not. So sorry about that. But there is the functionality, you start a server, you point it to a particular script, and then it automatically refreshes whenever you save the script. So that's a perfectly valid and nice way of working with this stack.
Okay, so I quickly go through some of the questions that were answered on Discord very quickly. Can I put another image in the background instead of the map? The answer is yes. HoloView underlying, so you use the multiplication dunder. See HoloView overlays. Next question, I deliver most of my plots using PySimple GUI. Do you know if these plots will show there? The answer was probably, but you haven't tried yet. Yep. And can we use HVPlot with Jupyter Lab? The answer is yes. And if you have any problems, then I think you can ask either on the official channels or on Discord. Any questions from the audience, or anything you would like to add to these questions I just read out before?
No, those were great questions. Thank you.
So far, there.
Another question about compatibility. How does HVPlot work with Streamlit? Does it work with Streamlit?
With Streamlit, so I think Streamlit does have support for embedding
bokeh plots.
Bokeh plots, that's correct. So in the end, it's just a bokeh plot. I showed you that command earlier, right? If you import Holoviews and then render to a bokeh plot, that should work directly. We do need to talk a little bit more with the Streamlit devs. Unfortunately, Streamlit does not have the same kind of bidirectional communication that Panel, for example, and the Bokeh server provide. And so a lot of the interactive features of dragging sliders, the interactive selections on plots, that kind of stuff won't work.
When you said you can share now your plots with somebody else and they can interact with that, do you mean you have to first deploy it somewhere and then?
So there's a few options there. The standard way is would be to basically stand up a server. It's integrated in Panel, so you basically just run panel serve and point it to the notebook, and then that deploys it as an application, or you can move it to a script. There's alternatives. So if it's a fairly simple app, there is an option to kind of embed all the states into the application itself. So I can try it here. So by calling this embed function on this panel object, it kind of goes through and kind of pre-records the state as I drag these sliders. I don't think it actually supports. So it doesn't support all the sliders, and so now this could be shared as a static HTML file. I have also been exploring. So if you've heard today, there was a talk about Jupyter Lite, which is a version of Jupyter that runs entirely in browser. I've been exploring the ability to actually run panel applications in PyData, which is what Jupyter Lite is built on. So you will very soon be able to kind of deploy panel applications entirely as browser-based applications.
So one more quick question.
Can we two?
No,
Only one. Okay. The HVPlot supports streaming data with a stream that are there some limitation or restriction which developer should be aware of?
In general, it works quite well. There is various examples, I hope, on the HVPlot documentation of using the streams library. If you kind of need more control, you kind of do have to drop down to the Holoviz API, which makes it possible to have so-called streams themselves. So you can create for example, a pipe, which is just some data, and then you can pipe that into your plot. So in this case, I could, I don't know, put my data frame in here, create a curve that kind of is fed by the stream. So there is good support for it. If you find issues, please report them. But yeah, as a starting point, I would recommend playing with the streams library and just seeing how far that gets you.
All right, thank you very much. Thank you for presenting. Let's thank our speakers again for this interesting